Good morning everyone, myself Darshan from CSE department at Venkateshwara Engineering College. Today I am here to explain about the introduction to face detection, definition and importance. Face detection is a computer vision technology that identifies and locates human face within digital image or video frame. Applications: Surveillance and security. Face detection is used in surveillance systems for identifying and tracking individuals in crowd areas, airports, and public places. Photography. In photography applications, face detection helps in achieving a better focus, exposure, and composition. Social media. Social media platforms employs for face detection for various purposes, including automatic tagging individuals in photos, creating personalized filters, and effect and enhancing user engagement through a feature like face morphing and animated emojis. Applications: Emotions analysis by detection, facial expression, face detection contribute to emotional analysis system that infer the emotional states of individuals. Human-computer interaction. Face detection enable a natural and interactive interaction between human and computers. Traditional approaches to face detection. The Vivogens algorithm introduced in 2001 by Michael Jones is one of the earliest of the most widely used method by real face detection. It operates by using a cascade boosted clarifier efficiently detect a face in image. The algorithm consists of a three keys components here like a further images and add boost are like features are simply rectangular patterns that capture a version in pixel intensities. That boost is used to select a small number of critical features and the trial of a weak clarifiers which are then combined into strong classifier. Traditional approach to face detection. Histogram of a oriented guarantees. Use is another traditional method for object detection. Include face detection introduced by Dell and Trax. It focuses on capturing a local object operations and shape by computing histogram of HOG operates by dividing the image into small cells, computing a guarantees histograms within each cell. The histogram values are then concreting to form a feature vector representing the entire image. Histogram of oriented guarantees. HOG is robust of varieties of lighting pose but may struggle with occlusion and complex backgrounds. Features engineering techniques. Features engineering involves manually designs or selecting discriminative features and capture important characteristics of face. Commonly used features include color information, texture description, and geometrical features. Color-based features can capture a skin tone hue variation, while texture feature engineering techniques. While effective in a certain skinners, features engineering may be limited by its reliance on handcraft features, which may not generalize well across different datasets or environment. Mechanical learning in face detection. SVM is a popular supervised learning algorithm used in a classification task including a face detection. In the context of the face detection, SVM learns a decision boundary that separates face image from non-face images based on extrinsic features. Features can include intensity, values, gradients, or other descriptors derived from the image. SVM aims to find the hyperplan that minimize the margin between different classes while minimize the classification errors. Decision trees. Decision trees are hierarchical structures used to classification and regression tasks. In a face detection, decision trees recursive plans that future space based in the learning threshold distinguish between face and non-face reasons. Random forest. Random forests are enable to learning a method that combine a multiple decision trees to improve a classification, accuracy, and robustness. In a face detection, random forest build a collection of a decision trees, each trying to subset a training data and results. Clustering techniques. Clustering algorithm group data appointed into clusters based on similarities in their features. In the context face detection, Clustering techniques can be used to identify a clustering pixel or images patches that corresponding to faces. Demonstratical reduced. Demonstratical reduction technically aim to reduce the number of features while preserving the most relevant information. Principal component analysis is widely used demonstration reduced technique that transformation high dimensional data into lower dimensional space while maximum difference. Deep learning technique in a face detection. Horticulture overview. CNNs are calls to deep neural networks designed specifically for processing a structured grid-like data such images. Deep learning techniques in a face detection. During a training, the network learns a minimized loss function by adjusting the weight of its parameters. Common losses functions for a classification task include therapy losses. Transfer learning. Overview. Transfer learning leverage knowledge gained from pre-training models on large database to improve the performance of a models on realized task limited data. Transfer learning. Fine-tuning strategies vary depending on the size of the target data set and similarities of the tasks. Data processing in face detection. Data balancing techniques. Imbalanced database where one classes is underrepresented compared to other can lead to based a model that performs properly on monetary classes. Normalization and standardization. Normalization and standardization are proposing a technique used to rescale the pixel value of images to common range, making them more suitable for training machine learning model. Normalize typically involves scaling pixel values to the range by dividing by the maximum pixel values. Evaluation matrix in a face detection. Recall measure a properties of correctly predicted positive symbol out of all actual positive symbol. F1 scores. Using and interpretation. Occurrence, precaution, and recall are commonly used to matrix for regulating face detection model. Choosing the right matrix. The choosing a evaluation matrix depends on the specific requirement and goals of the face detection and application. Challenges and limitations in a face detection. Occlusion poses a significant challenge to face detection algorithm as they may fail detect faces when a critical facial features hidden or partially covered. Pose variation. Illumination changes. Illumination changes occurs due to variation lighting conditions such as shadows, reflection, or direct sunlight. Illumination changes. Technical such as image pyramid representation while analyze image at multiple scales and multi-scales object detection algorithm can help address scale variation by detecting face at different resolution. Addressing multiple challenges. Conclusion. Addressing the challenges and illumination in the face detection require a combination of algorithm advancement, data illumination techniques, purpose methods, model operation strategies. Recent advance in face detection. Recent advancement in the hardware and algorithm have led to significant improve in real-time face detection system. Recent advance in face detection. Privacy concerns and ethical implementation. Privacy concerns and ethical implementation. Future directions. Future research in face detection is expected to focus on improving diverse dimorphical group environmental conditions. Recent advance in the face detection. Recent advance in face detection. Edge computing refers to the processing data locally at the device closer to the data source rather than replace. Privacy concerns and ethical implication. Privacy concerns and ethical implications. Cause studies applications of face detection. Causes studies application of face detection. Data analytics by analyze the patterns of a movement of behavior captured by smart cameras. Organization gain a valuable insight for optimized operation and enhancing safety measures. Facial recognition in security system. Facial recognition in security system. Adult trial facial recognition system maintain a digital record of a such event, enabling the organization to track a individual movement of a maintain accountability. Future direction in face detection. Robustness and generalization. Privacy presentation techniques. With the growing a concern about privacy and data security, future pays to save users' sensitive information. As a face detection system became an increasing complex and present a three in growing a transfers in their decision-making process. Cross-domain applications. Conclusion. In a conclusion, faces detection plays a pivotal role various domains from security in surveillance to entertainment and intelligence. Some are of the key points. Summary of the key points. Evaluation metrics like accuracy, precision, recall, F1 score, detection system guide a further improvements. Call to action for future research development as a technology continues involvement.